Okay, so hello and welcome back. In this video we will talk about the multiplication of matrices. Okay, now there is a very good example here that basically helps us understand the concept of matrix multiplication, and that is usually when you learn how to multiply matrices, you are told that, for example, if you have a matrix like, for example, 2, 5, 8, 10, and if you have this matrix, and if you multiply it by this matrix here, for example, 5, 50, you will get basically, this is a 2 by 2 matrix, this is a 2 by 1 matrix, therefore you will get a 2 by 1 matrix here, the same matrix as this. And then so then you will write your matrix as basically this row times this column, which is 2 times 5 plus 5 times 50, and then you have to multiply this row by this column, 8 times 5 plus 10 times 50, this is times 50, 10 times 50, and then you can write this as, for example, 10 plus 250 is 260, and this is 40 plus 500, this is 540, right? So almost everybody knows how to do this, and that's not a big deal, of course. And then, of course, there is a couple of rules that say that basically the number of columns of the first matrix has to be equal to the number of rows of the second matrix. If that's the case, then the two matrices can be multiplied. But the problem is that you don't really know why you do this. Although, and even when you go to university, when you take up a university course, or when you go to, well, when you start basically doing an engineering course or something like that, even in the first or second year of your course, you don't even know why you take this row and multiply it by this column and then you write it here, or why you take this row multiplied by this column, you write it here, and then this becomes the answer. And then some answer is supposed to be the correct answer. For that you get some mark, and if that's not the correct answer, you will not get the some marks. And that's basically how you usually live throughout your whole life, meaning that you usually don't really understand why you do what you're doing, and of course it doesn't make any sense. Now, through this simple example, it's actually possible to understand, for example, why we take basically this row and multiply it by this column, or why we take this row multiplied by this column and write it here, and so on and so forth, right? So now let's go through this example to understand the concept of matrix multiplication. So suppose that we have two friends, Mira and Nadim. Mira and Nadim, they want to buy some stationery supplies like notebooks, pens, and things like that. So Mira, what she needs is basically she needs 2 pens and basically 5 books, or 5 notebooks, let's say, or 5 notebooks, right? Nadim needs 8 pens, 10 notebooks. Nadim needs basically 8 pens and 10 storybooks, or I'm sorry, 10 notebooks. 10 notebooks, right? That's what they need. Now, they go to a shop and inquire about the price. The shopkeeper tells them that a pen, so basically the cost of a pen is basically a pen costs basically a pen costs 5 rupees. A pen costs 5 rupees, and basically a notebook costs 50 rupees, and a notebook costs 50 rupees. So that's basically the situation that we have here. Mira basically needs 2 pens and 5 notebooks. Mira needs 2 pens and 5 notebooks, and Nadim needs 8 pens and 10 notebooks. And the cost of basically each 1 pen is 5 rupees. The cost of 1 notebook is 50 rupees. What we want to know is that how much money does Mira need to buy all of these supplies, and how much money does Nadim need in of course in terms of rupees to buy all of the stuff, all of the supplies that he needs, right? So what I can do is that I can write this information 2, 5, 8, 10 in the form of a matrix. 2, 5, 8, 10. I can write this as in the form of a matrix, and then I can write the cost information in the form of a column matrix, meaning that basically I can write the 5 over here, and I can write the 50 over here in the form of a column matrix, right? Now, what do I need to do? What do I need to do in order to calculate the cost of, so basically 2 over here represents 2 pens, 5 over here represents 5 notebooks, 8 represents 8 pens, and 10 represents notebooks. So these are, this column over here is basically represents pens, and this column over here represents notebooks, right? And this row over here represents Mira, and this row over here represents Nadim. Now this row over here represents basically pen unit cost. This represents basically notebook unit cost, right? Now how do I basically put this information together in order to, or how do I really calculate, meaning that how do I multiply and add and so on and so forth, so that basically the cost for Mira is written as a total cost, and the cost for Nadim for buying basically 8 pens and 10 notebooks is represented as a total cost of the whole thing that he wants to buy. So I know that basically Mira needs 2 pens, and the unit cost of each pen is 5 rupees. So that would be basically 2 times 5, right? Which is 10 rupees. And I know that basically Mira again needs 5 notebooks. The cost of each notebook is 50 rupees. So that would be 5 plus 50 rupees, right? and so that's all the cost that basically Mira has to pay in order to buy her supplies. Now Nadim, on the other hand, wants 8 pence. That means 8 times 5 rupees. 8 times 5 rupees. And 10 notebooks, meaning that 10 times 50 rupees. Right? Now I can write this as a column matrix. It's possible for me to write it as a column matrix. It's possible for me to write it as a row matrix. I can do whatever I want to do with this as long as I know what I'm doing. And of course, this whole thing is just one number. This whole thing is of course one number or one entry. That means that I can write this as basically 10 plus 250, which is 260, and this number becomes basically 40 plus 500, which is 540. Which is 540. So then as a result, now in this matrix, this is the total cost for basically for Mira, and this is the total cost for Nadim. Right? Now, suppose that basically Mira and Nadim go to another shop and ask about the price of these supplies at the other shop. And we are assuming that basically, of course, it's usually the case that even the same items, well, you cannot really find that sort of thing in at least in Europe. You don't see that sort of thing because items are, I mean, everybody has their own types of items. For example, in a particular supermarket, the notebook that you see, the brand of that supermarket is on that notebook. The paper quality is different, and everything is basically different. So you cannot really compare, for example, a notebook with the same number of pages with another notebook with the same number of pages from another, for example, supermarket or something like that. So, but, well, when you go to India, of course, in India, this is possible. Meaning that you could go to another shop and you could get the same thing. Well, exactly, you could say exactly the same thing for a different price, right? Now, suppose that basically Mira and Nadim, they don't buy here, they go out and they go to another shop and then they inquire about the price of these supplies at the other shop. The other shop tells them that basically a pen costs basically, so this is shop number 2. This is shop number 2, tells them that a pen costs basically 4 rupees. Costs 4 rupees. And a notebook costs 40 rupees. And a notebook costs 40 rupees. Right? So that means that instead of this matrix, I can simply write 4 and 40. And then I can do the same thing that I did over here. I can still use the same matrix because the requirements have not changed, but the price has changed, right? So which means that I can write this as, I can write the result as a matrix as, for example, 2 times 2 is basically, 2 refers to pence, so 2 times 4 2 times 4 plus 5 times 40, 5 times 40, and then for Nadim you have 8 times 4, 8 times 4 plus 10 times 40, 10 times 40, which I can write as a column matrix, and then I can write it as this is 208, this is 208, and this is 440, right? So this is 440. Now, as you can see, what happens is that now basically Mira has to pay, instead of 260 rupees, she has to pay only 208 rupees, which is amazing. And Nadim has, instead of basically 540 rupees, he has to pay 440 rupees, 100 rupees less. And 100 rupees is a lot of money, of course. With 100 rupees, you can eat well, fairly well at a good restaurant in India. Of course, if you live in India, you already know that better than me. So that's now the situation, right? So now what I can do is that I can put all of this information together so that I don't have to do it, basically, I don't have to do to put these matrices together, basically in using different matrices. I can simply write the requirements over here, which is 2, 5, 8, 10. That is their requirements. And the price codes that they have gotten is 550, and 440. And 440. This is actually supposed to be 4 and 40. And so what happens is that then you will get 260 as a result of this operation. You will get 260, 540, and 208, 440. Right? Now actually let's do this operation, see if we actually get these numbers. So if I take again basically 2 and 5, this row is related to Mira, this row is related to Nadim. These are pens. These are pens and these are notebooks. This row is pens, this row is notebooks. And then over here we have the unit price for pen, the unit price for notebook, unit price for pen, unit price for notebook, right? So I can say that basically the number of pens times the unit price for notebook would be 2 times 5 plus the number of notebooks times the unit price for notebook, which is 5 times 50. And then I can do the same thing for basically for Nadim as well, meaning that the number of pens times the unit price for 10 for pens, and the number of notebooks times the unit price for notebooks. So that is 8 times 5 plus 10 times 50. 8 times 5 plus 10 times 50. And then you have basically, you can again do the same thing for Mira and Nadim for the shop number 2. So this is shop 1, this is shop 1, and this is shop 2, right? So I can do the same thing for shop 2 as well, meaning that I can say 2 times 4 plus 5 times 40, and then over here I can say So you have basically 2 times 5 times 40, and then I can say 8 times 4 plus 10 times 40. And then if I add these numbers together, I'll get basically that is 250. 250 plus 10 is 260. And you have 4, basically this is 200, and this is 208. And over here I have 500, 540, and over here I have 408. I'm sorry, 400, 8 times 4 is equal to 32. That is supposed to be 32. I have made a mistake here. This is 400, and that's 432. That's supposed to be 432. That means that here this is 432 actually. That is 432 here. And here I'm supposed to have actually 432. This is 400 plus 32 is 432. I apologize. Is 432, right? So you get the exact same matrix that we had here, 260, 208, 540, 432. Now, so you saw that basically we were multiplying, for example, 2 by 5, 5 by 2, 5 by 50, and 2 by 4, 5 by 40, and so on and so forth. So this operation by definition has been called the multiplication of matrices. Multiplication of matrices. And what that is basically what that means is that you can write actually 2, 5, for example, I'm writing from here, 2, 5, 8, 10, and actually multiply it by 5, 4, 50, 40, 5, 4, 50, 40, and that gives you this matrix, which is 260, 208, 540, and 432. That is matrix multiplication. Now that we understand the process, now we can basically make it a little bit more formal. Now the only problem that we had here is that you can see that basically in matrix multiplication, the only thing which is important is that we say that basically if you have a matrix, for example, we said that the requirements of Mira and Nadim was basically 2, 5, 8, 10, which is a 2 by 2 matrix. You have 2 rows, 2 columns. And the price quotes that they got were, for example, in the first one was, for example, 5 and 50. Now, if I want to multiply these two matrices together, if this represents, for example, if this row represents Mira, and if this row represents, for example, Nadim, right? And if this row represents pens, and if this row represents notebooks, and if this row represents basically, for example, pen unit price, and if this row represents, for example, notebook unit price, what happens is that, of course, if basically if I have a pen over here, there has to be if I have the number of pens over here, there has to be a pen unit price here so that I can multiply them together. If I have a notebook over here, or the number of notebooks here, there has to be the notebook unit price so that I can multiply them together. If they're not there, I wouldn't simply know what to do. That means that basically if I have that means that basically now this matrix is a 2 by 2 matrix, this matrix is a 2 by 1 matrix. And what that means is that this number here is supposed to be equal to this number, meaning that the number of columns that you have is supposed to be equal to the number of rows here. Meaning that you have 2 columns here, so basically you have basically 2 columns here, meaning that you take this row and multiply it by this, and multiply it by this. So as you can see, when I do the matrix multiplication, I take these 2 numbers and multiply them by these 2 numbers this way. The second time, I again take take these numbers and multiply them by the same numbers here. This is the second time. This is the first time, this is the second time. That means that I have 2 numbers over here, therefore I have to have 2 numbers over here. Now these 2 numbers is the number of columns here, which is this 2. And this 2 over here is the number of rows here, which is a 2 over here. Which means that when you multiply 2 matrices, the number of columns of the first matrix has to be equal to the number of rows of the second matrix. Otherwise, matrix multiplication is just basically not possible. Okay? So, therefore, based on everything that we talked about so far, we can formally talk about the matrix multiplication as follows. That is 275. Okay, so formally we can say that the product of 2 matrices A and B is defined. We can say that the product of two matrices A and B is defined if the number of columns of A, if the number of columns of A is equal to the number of rows of B. So the product of 2 matrices A and B is defined if the number of columns of A is equal to the number of rows of B. And we talked about this already. Now let's A be equal to, for example, A of ij, B and m by n matrix, A by n, m by n matrix, and B be equal to basically B of JK, be an n by P matrix, So I need to pay attention to what's going on here. So A is a matrix of order, A is a matrix of order m by n, and B is a matrix of order n by p. That means that the number of columns of A is equal to the number of rows of B, right? And you can see the same thing over here in the indices of the elements of A and B as well. Meaning that over here I have A of ij, and over here I have B of jk, meaning that the number of basically columns that I have is equal to the number of rows that I have here. J and j are equal, of course. And so then the product of the matrices A and B, then the product of the matrices A and B is the matrix C of order m by p. Is the matrix C of order basically m by p. Okay, of order m by p. To get the I, kth element, to get the I, kth element, which is C of I, j, C of ik, which means that basically the I, kth element would be basically in C would be basically the first row. No, I'm sorry, the last row, the last column, right? The last row, the last column. So to get the I, kth element C of ij of the matrix C, of the matrix C, we take the ith row of A, we take the ith row of A, actually A has to be this matrix, and kth column of B, and kth column of B. Multiply them element-wise. And take the sum of these products. And take the sum of these products. Right? In other words, if A is equal to if A is equal to basically a matrix A of ij of the order m by n, and B is a matrix of B of jk of the order n by p, then the ith row of A, of A is, so suppose that you have a matrix A of basically A of ij, which is an m by n matrix. Now the ith row of A would be of course A of I1, A of I2, all the way up to A of In, because the matrix is of the order m by n, so you have basically n columns over here, right? So that would be the ith row of A. And the kth column of B is, is basically, so the kth column of B is, so the column basically is always B1 or goes all the way up to n. So B is basically a matrix of the order n by p. Therefore the kth column of B is of course a column, is a column like this, and then you have B over here, lowercase b, and the column basically index is always k, and the rows start from 1, 2, 3, and so on and so forth. So you have 1k, B of, for example, 2k, B of all the way up to B of nk, because you have n rows over here, right? Then C of ik is equal to, so here we said that basically, in other words, if A is equal to this matrix and B is equal to this matrix, then the ith row of A is basically this row, and the kth column of B is basically this column. Then C of ik, meaning the element that is in the ith row and the kth column, right, in matrix C, is going to be equal to, so this is basically the ith row, and this is the kth column. So you have to take these elements and multiply them together element wise, and then add them together, right? Take the sum of all of take the sum of all of those products, right? So then you have, this is going to be equal to, for example, starting from here, A of I1 times, for example, B of 1k times B of 1k plus A of I2, for example, times B of 2k times B of 2k plus, for example, A of I3 times, for example, B of 3K, and you can go all the way up to basically A of IN plus all the way up to A of IN times B of NK, right? Which is the same thing as in sigma notation. You can write it as sigma of A of basically sigma of, this is A of I1, I2, I3, so and so on and so forth. So I need to, so if you want to write this in sigma notation, what you need to do is that, so of course you can see that A of I is repeating itself and is not changing. But there is an index here that is changing, which is 1, 2, 3, and so on and so forth, all the way up to N. On the other hand, here B1K, B2K, B3K, and so there is the same index running on B as well. So I can write this as A of I. It's not changing, so it doesn't have anything to do with the index. I can write it as A of I. And for this index, I can use, for example, some letter like J, for example, right? So this index is changing. Then again, B, the same index over here is changing, and K is not changing. And since we said that J was changing from 1 to N, then you can write for sigma of this expression as J goes from 1 to N, right? And therefore you can say that basically the matrix C is equal to basically C of IK M by P is the product of A is the product of A and B. Is the product of A and B, right? As an example, for example, if you have some matrix like, for example, C is equal to 1, -1, 2, and 0, 3, and 4, and if you have D as another matrix 2, 7, for example, -1, 1, and 5, -4, right? Then the product CD is defined, in meaning that basically this is a 2 by 3 matrix, and this is a basically 3 by 2 matrix. So since the number of this 3 over here is basically the number of columns of matrix C, this 3 over here is the number of rows of matrix D, these are basically equal, and therefore product C by C times D is defined, right? Or you can just simply say C times D, or you can write it as CD as well. And is given by CD is equal to basically, and given by CD is equal to this matrix, which is 1, -1, 2, 0, 3, and 4, right, times this matrix 2, 7, -1, 1, 5, -4. And of course this is going to be a 2 by 2 matrix. This, the matrix that you get here when you do the multiplication, of course, I'm going to, well, to be more cautious, I'm going to take this back because it's been a long time. I haven't used matrix notation in a long time. I don't want to unnecessarily give you wrong information. Maybe the cross product of vectors or determinants or something like that. I'm not really sure if I'm allowed to use this notation here, so I'm going to write it simply as CD as the product of C and D. So I haven't given you anything that I'm not certain about, right? Now this matrix over here is basically, this is a 2, you have a 2 over here and a 2 over here, and this matrix is a 2 by 2 matrix. If you do the multiplication here, you will get a 2 by 2 matrix, because you will take this row and multiply it by this column, write it here. We will take this row, multiply it by this column, write it here. Take this row, multiply by this column, right here. Take this row, multiply by this column, write it here. And then, of course, it becomes a 2 by 2 matrix. Okay. So, and if you want to, of course, we can actually do this operation. I'm sure you already know how that works. We have already done a couple of such, basically, matrix multiplications. But then you can write this as, so basically, first of all, you can basically write your matrix as basically a 2 by, you know that you're dealing with a 2 by 2 matrix, as we discussed before. So you have to start with, well, back then when I was younger, I used to deal with matrix multiplication a lot, because I was reading a couple of books. It was, I was back then in India, and I was reading this book, which was class 12. I was reading that for my basic mathematics in college. And so back then, what I used to do was that, of course, back then there was no notebook, no tablet or anything. Tablet was still not there yet. It was 2007, 8 or so. So of course we used to write everything on paper. And of course it's a much better way of writing things, but right now then I can't do that anymore. And moreover, I would go bankrupt if I were to write so much on paper, because I write probably 10, 12 hours a day. I just constantly write, so I would probably need 100 sheets of paper every day or so. Now, in order to know what you're doing, what you can do is that first you need to take this first column and multiply it by this first row, and multiply it by this first column. So you can put a mark over here and a mark over here. That means that this row is being multiplied by this column. And then, of course, you know that you have to write it up here, right? So basically the process is like this. So you have basically these elements here. You have these elements here, and you're multiplying this matrix by these elements, right? So when you want to do the operation, you have to basically do it like this. So first of all, you need to, since you know that basically you have 2 rows and 3 columns here, this is 2 by 3, and this is 3 by 2, and therefore you know that your matrix is going to be 2 by 2, right? Now, first of all, you will take this row and this column, and you write it here. This is number This is number 1. Number 2, you will take this row, this one, this one, this one, this one. So then number 2, you will take this one and multiply it by this and write it here. Number 3, you will move to the second row. So this would be number 3, and then you multiply it by here. So that is number 3. You write it over here. And then you need to do the same thing over here, number 4, and then but multiply it here, and then write it here, right? And that becomes your matrix. Now we will do this over here, and you will of course understand it. So what I'm going to do is that just mark the row and the column that you're working with, because sometimes the number of rows and columns of matrices get too large, and then you will get confused, especially if you're not good at arithmetic. When you do arithmetic in matrices of course are very arithmetic heavy. When you're doing arithmetic, you will get confused, and then you will lose track of basically where you were. That's the problem there. So you mark the matrices that way, and then you have to go this element with the first element here, the first element here, second, third, and third. So 1 times 2 is equal to 2. And you need to be also careful about the signs, because you can easily make mistakes. Now -1 times -1 is +1. And 2 times 5 is equal to 10. Right? So now this row is not still over, because I have to use the same row and now come over here. So 1 times 7, and now I have to write over here. So 1 times 7 is equal to 7. -1 times 1 is equal to -1. And you have to write it this way so that you don't make mistakes, right? 2 times -4 is -8. Now this row is over, so I have to move to this row. And so I start from this row and this column. 0 times 2 is equal to 0. 3 times -1 is equal to -3. And 4 times 5 is equal to 20. Now I have to stay at the same row, but then the second column, right? So 0 times 7 is equal to 7. 3 times 1 is equal to 3. And 4 times 4 is equal to -16. And of course, then you can close your matrix this way, and that's all about it. There is nothing complicated really about that. So, but you need to be focused, otherwise it's very easy to make mistakes in matrices. 10 plus 3 is equal to 13. That is -9 plus 7 is equal to -2. That is 20 minus 3 is equal to 17. And this is a 10 minus 16 is equal to -6. And that is your matrix. 13, -2, 17, -3. 10. I don't know what has happened here. 0. Actually, this is 0 times 7 is equal to, this is supposed to be 0 times 7 is equal to 0. And 3 times that's equal to 3. And 4 times that's -16, that's -13. As I said, you can actually very easily make mistakes. That's what I did. I didn't even notice it. So that's basically one of the exercises. Now, we have a couple of questions here. So let's let me finish this video, or end this video, I mean, and then we will continue with the rest of matrix multiplication in the next video. I'll see you in the next video, and thank you.